Good morning. Today we are going to see about radiation mechanism of an antenna. So this deals with two questions, and if you find the answer, then it's enough. So when does an antenna radiate and how does an antenna radiate? So before going to know about that radiation mechanism, you should know what is radiation. The electrical signal escaping into air or space as EM waves is called radiation. So if you want to create radiation, if you want to have radiation, you should have either of these two things. One is the time varying current or the acceleration or deceleration of charge. So when does it radiate? If you have the current or if you have the charge, when does it radiate? So you have the wire, a very simple wire, and it is a conductor. And if it is right, and through that wire you have the time varying current, then definitely you have that radiation. Or you have the wire and that wire is curved, bent, discontinuous, terminated, and in that you have the acceleration or deceleration of charge, then on that case also you would have the radiation. That's it about the radiation. But how the acceleration happens or deceleration of charge happens? This acceleration happens because of application of this electric field, that means excitation. And the deceleration of charge is due to the curves or impedance in discontinuities in the wire. Okay, so with that actually the concept is over. Now we can see the cases one by one. So here you have a case 1 in which we have the static charge. So you have only the static charge. There is no acceleration or deceleration of charge, so it won't radiate. Case 2, you have the wire but there is no current, no AC current, so it won't radiate. The third case, you have the straight lengthy, that means infinite in length conductor wire, and here you have the current, but the thing is it is having uniform velocity, so it will not radiate. It is not a time varying one. Okay, so it will not radiate. So case 1, case 2, case 3 already we have seen. So it will not radiate. That is the answer. Okay, now we go for the fourth case. You have the wires, simple wire, but it has the bend. If you have the bend, definitely it will radiate. And the fifth case is you have the curve, smooth curve in the wire. So here you have the radiation. Here you have two wires and the impedance discontinuity is there at this point, means at that time you will be having the radiation. So this radiates. Then case 7. So here you have the wire. It is being properly terminated using this impedance, that load impedance, right? So it is being properly terminated. If it is, in that case also it radiates. So yes, it is radiating. And the seventh case is over eighth cases. The wire is being truncated, and here you have the current flow. Definitely at that time the radiation occurs. Okay, so the answer is already given for these three cases, and for the fourth, fifth case, yes, it radiates. Yes, these two cases, and for this case also you have the radiation. With that, the concept is over. Okay, I hope that you might have understood, but I want to make the analogy of this radiation with the leakage. Okay, the radiation itself is the loss of energy, So electrical energy is being lost because of discontinuity, because of alternating current, because of the bend. So many factors are there. Okay. So if you have that kind of energy loss, then the electrical signal is escaping into the air or space, so that you have the EM waves are being radiated. Okay, that is the concept. So for that, definitely you should have the current flow, right? So I want to have that analogy of this electromagnetic radiation with the automobile or with the hydraulic. So here we are talking about the static charge. If you have the static charge, means it is not at all moving. If the charge is moving, then only it is called as current. Okay, movement of charges is called as, movement of flow of electrons is called as current. Okay, so here you have the icebergs or ice cubes or a water being stagnated or being stored inside a container, then there is no flow at all, no flow of water. No flow of water is equated to no flow of current. So there is no current, definitely there is no radiation at all, no loss at all, no leakage at all. Okay, no radiation. If you take the second case, here there is no current. If you take the second case, here the vehicle is there, here the container is there, the wire is there, but no current. Here no petrol, here no water. So definitely there is no talking about the leakage, no energy loss, so no radiation. In this case, the third case, you have the conductor, you have the current, but it is moving very smoothly with a uniform velocity. Here also you have the straight canal, so the water is flowing very smoothly. So there won't be any possibility of leakage of water outside this canal. Okay. So it is flowing anyhow. So no radiation, no leakage. Here the biker is racing. Here there is no need of applying the brake because it is a very straight road. Okay, so no loss of petrol. So that can be considered as no radiation. Okay, that can be equated to no radiation. Then the fourth case, here you have the bend. Okay, so on the bend means definitely you have the radiation. Here when we talk about this, when we see about this automobile, here you have the 90-degree turn, right? So on that time, definitely the driver has to apply the brakes and loss of energy, loss of petrol, something like that, right? So here, loss in the sense that can be equated to radiation. Here the twist and turns and the bending. So if it take actually if it persists, what happens, automatically some crack will be appearing at this point and leakage of water will be there when water flows. Similarly here also, if it is coming with the water is flowing with the force, definitely there are chances of having leakages at this bending points instead. So similar to this, we have this bend for this wire, so radiation occurs. So here you have a smooth curve. So here automobile, if you take this is a smooth curve, anyhow the driver has to be so much careful in applying brakes and all. So here we have some loss of energy, and here also you have the bending. There are chances of having leakages if it is not properly done, right? So this is radiation occurs. And here we have the impedance discontinuity in the wire because of this diametric differences, and no proper impedance matching is done means radiation occurs. So this is the best example here. You might have connected different dimensional pipes, But if they are not properly connected, then you will be having the leakage. Leakage is equated to radiation. Okay, so the radiation occurs. And the next case is here, the wire is being terminated, so it properly, you have the proper end, you have the proper end, but even then the radiation occurs here. Why? Because here you can have the comparison with the dam. So the water is flowing. So if we stop the flow of the water by constructing the dam, definitely there will be some leakages. Okay, small leakages will be there. And here the dead end of this road, so it is at the cliff. Okay, so you would be struggling a lot and you are wasting your energy there to come back or something like that, right? So here the energy is lost, so radiation occurs. Truncated means it is being cut, so the wire is cut and the current is flowing through that, then definitely you have the radiation. And here you have a cracked road, and if you are traveling by a vehicle, definitely you would struggle a lot, and there would be loss of energy, there would be loss of some fuel when you are applying brakes and all. Okay, so all these 8 cases are given you in your book. So I have given the answers also, already I have given. That's it, we have considered all those cases. So I hope that you have understood the concept of radiation very well for a simple wire. Okay, it's a single wire. Thank you.